which adapts a fiber optic cable. We have a strain relief is what this is, just to hold and support the cable. Because these cables can't be bent right angle. I mean, 2 inch, 2.5 inches, okay, but right angle, you're going to break that fiber inside, that single core fiber. These are very durable. There are 2 types of lenses as well. We have a larger lens, which we call a 25 millimeter or 1 inch lens. That's the diameter of the tube. The glass lens sits inside. You could focus this by loosening this knurled ring and just pulling out this barrel, pushing the barrel in. That's how you focus. Because the laser, you turn the laser on, it will come out, project out of the lens onto your target. When you get the smallest laser, that's where you know your focal point is. Then there's also a miniature lens. And, you know, this is a less than a 12 millimeter, less than a ½ inch diameter. And this also has adjustable focus via an Allen screw. You loosen the Allen screw and you slide this tube back and forth, and then you can focus with the laser coming out. This can focus up to 24 inches, where, you know, on the larger lens you could go out to 15, 17 feet. And this just illustrates the dimensions of the pyrometer. Now you grab the connector, push it in, pull it out through the lens. You get the larger lens and the mini lens assembly. An extruded housing, so it's rectangular in shape and it has a groove on the bottom. And in that groove, we have accessories such as swivel base mounts that allows you to slide this in with the 2 plates, and then you can loosen it up and swivel the pyrometer in any direction. This just shows, depicts different items in the fiber optic sensor, the lens, the fiber optic cable, the strain relief, and the pyrometer, and for a temperature sensor. We put these in packages. As a value added, we package the pyrometer in a box similar to this one here. And instead of having a touchscreen display, we put the pyrometer in this package. And with a power supply, with all the connectors, RS-232 connector to configure the pyrometer, or with the industrial connectors for quick disconnect for power, AC power, as well as getting the output signals. So we've mounted the pyrometer here. Here you can see the fiber optic coming out. And we offer this as well. I was talking earlier about the different applications and why fiber optics are used. But we do have, for vacuum applications, we have a fiber optic cable where you can actually put a sleeve here and you can get a swage lock or some compression fitting and use that. So on one of these ends of the fiber optic cable, you'll have a lens assembly, and the other end will be the pyrometer. So you can actually snake this through a gland or a fitting on a vacuum chamber, a pressurized chamber, and put the lens inside the chamber. Also, you could use that feed through in bulkheads, like for nuclear applications. You run this through a bulkhead, and you have the fiber inside, and you have the electronics outside nuclear environments or radiating environments. This is a special cable. So what we ask if you have a vacuum application is how far you want to mount the sensor from the chamber, and also from where the chamber wall is to where the lens is. Because we have to position this is a stainless steel sleeve that's got vacuum compatible epoxy. We got to position that in the length where you want it along the cable. Here are the reasons, again, for fiber optics. They're small and flexible. They're immune to high magnetic fields. High ambient temperatures of 300 C they could be subject to, and you could use them for vacuum applications. We've also taken this sensor, so the number of these, the centering application was one of them, and we've applied the lenses, fiber optic, We have an air purge. With a fiber optic adapter, it adapts directly to this air purge assembly with a mounting bracket. And there you look down at either a sight tube or you can look down a closed-end target tube. So we provided the customer here, actually he was in Indiana, I believe. Yeah. We had a box here. The customer wanted a local temperature display. And here we had the pyrometer. And a fiber optic cable, a long fiber optic cable that went on top of a distribution area glass plant. So it was measured molten glass.